algae are the very first vegetal organisms to have appeared on Earth. They can be found in all aquatic environments. Enlarged by electron microscopy, they look very similar to jewelry. They are diatoms, microalgae. With over 100,000 species known to date, diatoms represent the most important group of algae in the vegetal plankton world, at the base of the aquatic food chain. In spite of their minute size, they possess genuine machinery for photosynthesis.
Photosynthesis is one of the most incredibly sophisticated, regulated biological machines that we know about.
Without the magic of photosynthesis, there would be no oxygen in the atmosphere. Life would be rare.
Planet Earth is receiving enough solar energy per hour to power all of mankind's energy requirements for an entire year.
1 hour of sun for an entire year of energy. A humiliation to humankind still struggling to find efficient ways of capturing sunlight to produce energy.
Plants have had 3.5 billion years to work out how to turn the energy from sunlight into food. They're pretty good at it. And how they do this is what we've found to be quite mysterious.
The sun's light is so powerful that plants have developed stop and start security mechanisms to avoid overheating.
The capture of this energy is so efficient that it needs to be highly regulated because it can provide too much energy to the other parts of the plant. So some of that energy needs to be dissipated when the sun's bright. And that happens by turning on safety valves. These safety valves take the excess energy and dump it as harmless heat rather than destroying the plant.
It is these tiny pores, called stomata, that regulate the gaseous and energetic exchanges in plants during photosynthesis. Plants undergo complex energy transfers at unbelievable speeds.
The capture of sunlight and moving through space happens incredibly fast. We can't even imagine this in our normal lives as femtoseconds, it's called, 10 to the minus 15 of a second.
A femtosecond is to a second what a second is to approximately 31.7 million years. A staggering rapidity for these plants whose metabolism seems so slow. Gregory Scholz discovered that plants use quantum physics in order to optimize photosynthesis. The sun's energy particles absorbed by the plant can be found in 2 different locations at precisely the same time.
Can actually take 2 pathways or 3 pathways simultaneously. It was unimaginable just a few years ago that this could happen in something that just grows outside.
The tireless quest for light may well be the reason for the immense global surface deployed by plants. While the skin of a human being covers an average of 2 square meters, scientists estimate that the leaves of a tree 15 meters high covers a surface area of 200 hectares, which is roughly the size of Monaco. The immense surface of leaves optimize photosynthesis. For each ton of vegetal biomass produced, nearly 1.4 tons of oxygen is added to the atmosphere, and 1.8 tons of carbon dioxide is eliminated. Plants have the power to absorb carbon dioxide, a greenhouse effect gas that participates in global warming, and as a byproduct, they release oxygen. Plants have the power to clean the planet. During photosynthesis, plants release oxygen from their roots. These attract partners that are essential to plants. countless bacteria that will devour the polluting organic matter. In 1974, a revolutionary and natural wastewater treatment system was installed at the NASA Stennis Space Center to filter the wastewater of both homes and laboratories.
We install plants, water hyacinths, floating tropical and semi-tropical water hyacinths with a beautiful flower, to treat all the waste at this large NASA facility, which houses about 5,000 or 6,000 people.
The research aimed to demonstrate the capacity of plants to transform dirty water into food, oxygen, and water. And this 1.2-hectare lagoon has largely met the wastewater elimination requirements set out by NASA. Today, hidden beneath its leaves are alligators and fish. And the life of the lagoon is humming with birds and insects, as in a natural environment. The system has functioned for over 40 years. Maintenance is limited to evacuating the large quantity of hyacinths once a year. The plants have magnificently adapted to this environment.
These water hyacinths, if you take them out of a river or the natural environment, they will have a large root system because they are seeking the nutrients and minerals they need. But once we put them in where we have domestic sewage mixed with them, they have all the nutrients they need, and you can see here they're a small root system because they don't need this massive root system that you will see if you pull this out of the river.
Biological stations using lagoon water hyacinths represent only 5% of installation costs and 10% of maintenance costs of industrial wastewater treatment stations. If these plants are so far ahead of us when it comes to depollution, why are today's engineers not inspired?
One of the reasons it has been slow to be implemented is because it is simple, and most civil engineers that design wastewater treatment systems do not understand how plants have such magic and power.
Plants are not only capable of cleaning wastewater. In addition, they are incredible at cleaning and filtering air, each species having its own specialty.
Large trees are cleaning factors. The more large trees you have, the cleaner your air is going to be.
Bill Wolverton affirms that plants also give excellent results in the elimination of radioactive elements like cesium-130, strontium-90, and cobalt found in contaminated soils.
In Japan, where they've had this serious problem, over the years they found that sunflowers are very effective. So they're using sunflower plants now to remove soil from their fields near this horrible accident, nuclear power plant failure. And it may take some time.
If plants have become our allies in depolluting the air and soil, they equally contribute to purifying the air of our interiors. To test the capacity of plants to produce fresh air under shelter, NASA led the BioHome experiment, an airtight building built of completely synthetic materials. Before introducing the plants, the men inside the structure, devoid of plants, had stinging eyes, sore throats, and respiratory difficulties. After introducing plants covering half of the surface inside the home, the symptoms disappeared in just a few days.
If you're going to live in a permanent, tightly sealed building, whether it's on Earth or in outer space, you're going to have a bioregenerative process, plants and their root microbes. If you can't build a tightly sealed, energy-efficient building with plants and maintain healthy air in it, that's step number one before you try to build a more complicated system on the moon where you have to create all of the oxygen.
If fresh air is essential for astronauts, it is just as essential to Earthlings.
The U.S. Environmental Protection Agency has identified indoor air pollution as one of the most serious health problems facing the Americans.
Bill Wolverton encourages the use of plants in order to grow fresh air. For him, all modern homes are concerned, as they are full of volatile and invisible chemical products. Before the 20th century, chemical products were virtually unheard of. Today, we use more than 80,000, and they have invaded our everyday lives.
Practically everything in your home is made of synthetic materials. That is, chemicals, the TVs, your computers, the paint, the paneling. With our modern buildings with synthetic materials, when we seal them up to make them energy efficient, we seal up hundreds of nasty chemicals that cause health problems.
In order to fight against energy loss, the tendency is to increase the construction of airtight buildings.
How do you build such a tightly sealed, energy-efficient building and maintain healthy air? And the answer is plants. The whole key is to educate the world of how nature can be used to clean our environment and make it a healthy environment, and nature has the answer. If we will only look to nature and work with nature, we can get out of this mess that we're in. But are we too arrogant to do it?